Hello everyone, welcome to my channel Chemistry is Fun. Today we will discuss the chapter of chemistry. The chapter is of solutions and this is part 9 of the chapter. We are discussing it for class 12 students of CBSE. The other board students also can follow. First of all, we will study what are colligative properties. See, there are certain properties which depend on number of solute particles irrespective of their nature. Only number of solute particles relative to the total number of particles present in the solution, means we should take into account number of solute particles and the total number of particles which are present in the solution. So we will study colligative properties one by one. Today we will see relative lowering of vapor pressure. So we know that there is a relationship between the vapor pressure of solution and mole fraction and vapor pressure of pure solvent. So if we take vapor pressure of solution as P1 and its mole fraction as X1 for the solution and vapor pressure of pure solvent is P1 naught, then P1 is equal to X1 into P1 naught. P1 is equal to X1 into P1 naught. The reduction in vapor pressure of the solvent will be represented by delta P1. And this is the reduction in vapor pressure. So the vapor pressure is decreasing. So that reduction will be given by P1 naught minus P1. P1 naught minus P1, because P1 naught is the vapor pressure of pure solvent minus P1. P1 is the vapor pressure of solution. So when we subtract it, we get delta P1, that is reduction in vapor pressure of the solvent. But we know that P1 is equal to X1 into P1 naught. So here in place of P1 we put this value P1 naught X1. Taking P1 naught common, we get P1 naught into 1 minus X1. But 1 minus X1 is equal to X2. So delta P1 is equal to X2 into P1 naught. I am repeating again. Delta P1, reduction in vapor pressure of the solvent, is equal to X2 into P1 naught. Okay. So in a solution which is having several non-volatile solutes, the lowering of vapor pressure will depend on sum of the mole fraction of different solutes. See, there are more than one solutes, all are non-volatile. So lowering of vapor pressure will depend on sum of the mole fractions of the different solutes. So with the equation, we can write that delta P1 by P1 naught equal to X2. That is mole fraction of the solute. X2 is mole fraction of solute. So this relation delta P1 by P1 naught. Delta P1 was the reduction in vapor pressure. Its ratio with P1 naught gives that will be equal to X2, that is mole fraction of the solute. But delta P1 is equal to P1 naught minus P1. So here we get this full equation. P1 naught minus P1 divided by P1 naught equal to X2 mole fraction of solute. This is relative lowering of vapor pressure and it is equal to the mole fraction of the solute. But how we will get the mole fraction of the solute? X2 is equal to N2 divided by N1 plus N2. Here N1 and N2 are the number of moles of solvent and solute respectively. N2 is for the solute. N1 and N2 are number of moles of solvent and solute respectively. In case of dilute solutions, N2 is very much less than N1. In case of dilute solutions, N2 is very much less than N1. So N2 by N1 plus N2 gets reduced to N2 by N1. That is equal to W2 by M2. N2 is W2 by M2. N1 is W1 by M1. So N2 by N1 becomes W2 by M2 into M1 by W1. Here W1 and W2 are the masses. M1 and M2 are the molar masses of the solvent and the solute respectively. Now related to this, let us solve one numerical. The question is calculate the vapor pressure lowering, which is caused by addition of 50 gram of sucrose whose molecular mass is 342 to 500 gram of water if vapor pressure of pure water at 25 degrees C is 23.8 millimeters mercury. This is the given question. Now as per Raoult's law, P naught minus Ps divided by P naught, that will be equal to n by n plus n, which you have seen just now, n2 by n1 plus n2, same thing. So P naught minus Ps is delta P, that is equal to n by n plus n into P naught. Now what is n? N is 50 by 342 because 50 is the gram of glucose given, 342 is molecular mass. So what we have seen here, no, W2 by M2, this one. So this is equal to 50 by 342, which comes to be 0.146. N will be 500 by 18. This is for water, this one. 500 grams given. So 500 by 18, we get N as 27.78. P naught is 23.8. Putting all the values, we get delta P as 0.124 millimeter mercury. 0.124 millimeter of mercury. Students, I hope you all could understand the topic and the numerical which I discussed today. Please subscribe to the channel because I will be uploading videos and we'll discuss numericals which are very important for your exams. Thanks for watching. Please share the video and subscribe to the channel. Thank you all.